When you're finding the domain of a radical, the first thing you want to ask yourself is this an odd root? So that's if it's a cubed root or a fifth root or any root where the little index here is an odd number. If it is an odd root, then right away your domain is going to be that x, or our input, can be anything we want. So x is in the real numbers. But if it's an even root, so that would be a square root or a fourth root or anywhere where the index is an even number, you're going to set the discriminant, which is that stuff underneath the radical, to greater than or equal to 0, and then you're going to solve for x. So this question says, what is the domain of y equals the square root of x? Well, according to our first step, we check and see, is this an even root or an odd root? There's nothing there that's a squared root. There's like a little invisible 2 there. So this is an even root, which means anything that's inside here all together, so x is everything inside there, had better be greater than or equal to 0. So it had better be positive or 0. Now I'm going to solve for x, but I already have x by itself. So this tells me all the information I need about the domain. This question is, what is the domain of y equals the square root of 3x plus 4? So again, it's a square root, so I do need to take all the stuff on the inside, 3x plus 4, set it to being greater than or equal to 0, because all that stuff in there had better equal something that's bigger than or equal to 0. And now I'm going to solve for x. So just like as if it was an equal sign, I can move the 4 over by subtracting 4. So I'll get 3 x's are bigger than or equal to 0. Divide by 3. Oops. That should actually be negative 4. 0 minus 4 is negative 4. Divide both sides by 3. And I'm left with x has got to be bigger than or equal to negative 4 over 3. And that's my domain. What's the domain of y equals negative 2x plus 8? So again, I take a look and it's squared root, so that means I do need to take everything on the inside and make it bigger than or equal to 0, and now solve. So take away that 8, so I have negative 2x is bigger than or equal to negative 8. Now when I divide, I'm going to divide by a negative number. And remember, when you divide by a negative number and you're dealing with inequalities, you're actually switching everything around. So as soon as you divide by a negative number, you take this little alligator inequality and you flip it around. So now I have x is not greater than or equal to, but less than or equal to negative 8 divided by negative 2, which is positive 4. So what is the domain of y equals the cubed root of 2x? Well, step 1 is looking at what kind of root I have. So this is an odd root, which means it doesn't matter if it's a positive answer or a negative or a 0 in here, anything goes. So because it's odd, my domain is that my x's just have to be in the set of real numbers, which basically means x can be anything that I want it to be. So just to recap, when you're finding the domain of a radical, the first thing you do is you're going to take whatever's under there and set it as greater than or equal to 0, and then solve for x. But remember, if it's an odd root, the domain is automatically x is in the real numbers. And also remember that when you divide by a negative number, that inequality sign needs to flip around so that it now says less than or equal to instead of greater than equal to.